Croft is a distinguished university professor in the Department of Computer Science at University of Massachusetts Amherst, which he joined in 1979. In 1992, he founded the Center for Intelligent Information Retrieval, CIIR, which is very well known in the IR community, which combines basic research with the technology transport to a variety of government and industry partners. Professor Croft was the chair of the department from 2001 to 2007. Professor Croft received a bachelor degree and master degree in computer science from Australia. His PhD degree is in computer science from University of Cambridge, England in 1979. His research interests are in many areas and applications of information retrieval, including retrieval models, representation, web search, query processing, cross-lingual retrieval, and search architectures. He has published more than 200 articles on these and other objects, which has been involved in the organization of many workshops and conferences. Through the joint Lemur project with Carnegie Mellon University, his group has provided open source search engines and research tools to many academic and industry IR communities. Professor Croft has been a member of National Research Council, Computer Science and Telecommunication Board. He was editor-in-chief of ACM Transactions on Information Systems. He was elected a fellow of ACM in 1997, received a research award from the American Society for Information Science and Technology in 2000, and received the Sultan Award from ACM Special Interest Group in Information Retrieval in 2003. So it's really our great honor to have our leader in information retrieval, Professor Croft.
Thank you. Thank you for the introduction. Is that volume okay for people up in the back there? Yeah? Good. Okay, so what I wanted to talk about today is, in the title there, information retrieval with ephemeral data. And this covers a range of research that we have started up in my group over the last couple of years, really. And also research that's becoming more popular in information retrieval and other fields as well, basically in response to the huge amount of information coming from social applications these days. So what I want to talk about is what's interesting about this data and what sorts of research are people doing these days from the information retrieval perspective, because clearly a lot of different groups in computer science are interested in this data and what research they can do with it. So what I'm going to do is to talk about social applications and what I mean by ephemeral data, and then talk about the characteristics of that type of data and how it might differ from typical data on web pages or in other types of search systems. Then talk about a little bit about the particular challenges of working with this data and evaluating research in this area. And to do that, I'll in particular focus on some examples of research that we're doing in my center. And I'll be only able to cover these superficially because I want to cover a number of different examples. But hopefully they'll give you a sense for what may be interesting to look at in this area. And I'll finish with some discussion of future directions that I can see as being interesting. Okay, ephemeral information. It's a bit of a mouthful, I know, but I got sick of talking about social data and social media, so I thought let's start calling it ephemeral data. So let's try and justify why one might call it ephemeral data. So what I'm talking about is information created by social applications, and there's a lot of those social applications like Twitter, Facebook, and many others. And we're all increasingly familiar with that type of application. And these applications are being used to create huge amounts of information. Now, a lot of that information in applications like Twitter or Facebook, or even more extreme, SMS, for example, another form of social application. A lot of that information is generated very spontaneously by people, and it's generated as part of conversations, typically, in response to messages from other people, And certainly it's for communication between friends, acquaintances, and groups, communities in general. Often this information is generated with very little thought about the style and substance of what you're generating, the format or the lasting value of what you're saying. It's generated fairly spontaneously. And so this is what I'm talking about with ephemeral here. There's a dictionary definition I just pulled off the web, lasting only a short time. And from the user's perspective, that's a reasonable way to view this information, that people are just thinking of it as something in the moment, some information that's generated in response to a conversation, etc. And in particular, we can contrast this type of information with archival information, which is a lot of what we read when we read things on the web. Things like news sites, scholarly papers, company websites, Wikipedia articles, anything with a more formal aspect to it. And these types of sources are designed to be read over longer periods of time. I'm not saying they don't change, but they have a longer time frame associated with them. They're designed to be read by large audiences of people, which is not characteristic of the sort of things that are generated in most social applications. So, ephemeral information, archival information. I would say that they're really defining extremes as we talk about, like SMS data versus a journal article, as ephemeral on one end and archival on the other end. I would claim most information lies on a spectrum between these extremes, where the spectrum's defined by the sort of time scale associated with the information and the quantity of information in each posting or document associated with it, and to some extent the quality of the information as well. Time scale, a lot of social information is very timely, very responsive to events that have just occurred. And as I keep using SMS, that's my whipping boy, so to speak, of social data as being an example of something that's very fast time scale, reply, almost synchronous responses, etc. And then we move up to things like forum posts, which have a longer time scale, but still you get responses pretty quickly in a lot of forums, and they're often responding to things that have just occurred and stuff like that. And as opposed to, say, articles in a news site, I'm talking about the articles here, where they do change over time. We get more news about events occurring and the news stories change, but the time frame for the changes and the responses to what you see in reading the articles is a lot longer than the typical time frame of what happens in the conversations in social media. So that's one of the dimensions that we see this variability. Then there's the actual amount of information, or at least the amount of words associated with the posts in these different applications. So tweets obviously are short. Blog posts can be longer. Some are quite long. So others are short. Forum posts also vary between single word postings and quite long postings, but tend to be on the short end. Then we move up to, say, Wikipedia articles, journal papers, theses, etc., which get longer and longer and longer. So that's another one of the dimensions. And the third dimension, I talked about the quality of the information, obviously a subjective aspect of information. But it is related to quantity, and most people would say that a lot of what you see on Twitter is not particularly high quality, although it might be meaningful to a small number of individuals. But from the general perspective, it's certainly not high quality information. Whereas journal articles and things like that, longer, more thoughtful pieces, you say, okay, they're of more value to more people, so higher quality. But as I said, this is a general rule. There are very informative tweets, and people have all seen examples of very informative tweets. And there's also lots and lots of long spam websites which have got just a bunch of junk in them, and certainly of very low quality. But in general, there is a quality dimension associated that varies from archival information to ephemeral information. Okay. So if we accept that there's ephemeral data, which is generally generated by social media and social applications, versus archival data, which are generated in a more thoughtful way maybe, the important thing from the information retrieval perspective or search perspective is that this social or ephemeral data can be a really unique resource for finding interesting information. Okay, so this is one of the main points of what I'm talking about here, is that because they involve discussions about between communities, then a lot of information and knowledge can accrue in these discussions, even though a lot of the individual postings might be short, even meaningless, or relatively uninformative. As a whole, if you look at a whole thread of a conversation, you can often pick up a lot of interesting and unique information about what is being discussed. And you think of all the different forums that we all look at from time to time, whether it's product discussions, whether it's discussions about your favorite online game, or whether it's some technical area in computer science, a forum or some type of social media application like that is often where you find a key piece of information. And you're also more likely to find unfiltered opinions in social data than you will in carefully edited pieces in archival forums or archival situations like news articles and things like that. So and a number of people have noticed that it's a very useful data set to mine for opinions about things. Okay, so this brings me to really my key hypothesis for looking at it from information retrieval perspective is that ephemeral data can have lasting value. So it sounds almost contradictory, but remember I'm defining ephemeral from the point of view of the generator of the information. It doesn't mean that what's generated can't have lasting value. In fact, there's many, many examples of old social media being useful to answer current problems. And so that's why we're interested in it from the search perspective. How can we provide effective search techniques to search this more informal, lower quality, shorter stuff in such a way that we can find good answers to problems that are not readily available in some of the archival materials. And you see a bit of this on current web search where you get some forum postings retrieved. Occasionally you get a Twitter posting retrieved. But in fact, the techniques being used there are fairly simple, and what we're looking at is developing these techniques in the search tasks that we in the community are defining and investigating now. So, most of you are aware there's a lot of research going on, as I mentioned, in social media, not just on search. People are looking at the social network aspects and analyzing it as a network and recovering links and predicting links and things like that. Discovering trending topics and correlating those trends with other time series like stock markets or natural disasters. We've all seen public media discussions of those, and a number of you probably read the literature that is going on associated with this type of research. And as I mentioned, a number of people are starting to look at it as an interesting source for opinion mining or sentiment analysis research. I do information retrieval, so what we're interested in is developing retrieval models and representations of social media documents that enable us to exploit the characteristics of social data to provide effective answers to questions. Our business is search, finding good answers to a whole range of different questions. So we have to understand what are the questions that are applicable for this type of data, what are the characteristics of the data, how do we model those characteristics and queries in formal models which can result in effective ranking functions. That's the business of search. That's what we work on. So that's what we're interested in. But with social media, we're interested both in general or global search, which is when you might search Twitter for some topic. That's a global search. You're searching everybody's stuff for some topic you're interested in, versus personal search, which is searching the stuff that comes to you. That's a whole different field, or maybe filtering the stuff that's coming to you, reordering it, ranking it according to your preferences, etc. So these are two different aspects of the research on social media. And the personal search is particularly interesting with social media because social media is all about I'll take that back. A lot of social media is about personal communication and stuff that's important to you and not particularly important to anybody else outside your circle of friends. So it's an important aspect to consider. You know, a lot of just considering global search doesn't, it ignores some important aspect of social media. Okay, so we want to look at retrieval models, which are mathematical models of the search process and the representation in order to generate ranking functions to do search. And the way we evaluate our models is to test them using a standard IR approach, which has become a standard approach for many other areas of applied language processing now, which is that you have a test collection of data and you define search tasks, and associated with those search tasks you generate queries, and then you get assessments from people, preferably the people who generated the queries, but if not, other people. You get assessments about how relevant various pieces of information in your test collection are for the queries. Okay, so that's our training data and our evaluation data, and we try to get as much of it as possible, and we use all sorts of variations on that, such as click data as being an approximation to relevance data and things like that. So we spend a lot of time in our community worrying about how to evaluate our research and where to get this data from to do the evaluation. Generally speaking, it requires documents, queries, and relevance judgments. And the best example of this stuff is the Trek Forum, which has been held every year for nearly 20 years now. I think it's the 20th year next year. And within that forum, researchers define tracks, and each track really corresponds to one or more search tasks which people consider interesting. And so then the community gathers data for each of those search tasks or tracks, and then the researchers can go off and compare their algorithms for accomplishing that search task. And that's how we've made a lot of progress in search over the last 20 years. And it's a good way of doing things. There have been recently some Trek tracks that are related to social media. In particular, there was a blog search track which ran for about 3 years recently. And this year is the first year of the microblog search track, which I'll talk a bit about later on. Personal social search and personal filtering of social media are just inherently more difficult to evaluate. These Trek collections are shared between all the researchers. They inherently focus on global search. If you want to do personal search, then you're starting to, the first thing that everybody says, which I've heard from about half the people I've talked to here, is that privacy. If you want to do personal search, then I have to get your collection of Twitter and Facebook and stuff like that, and I have to get your cooperation to evaluate how well I'm doing in filtering it or ranking it or other things like that. I can't abstract away from people very easily. So we need individual preferences, very individual judgments, and it's a whole level of difficulty beyond what we've typically tackled in Trek. So there's an issue there about how you do it, and I'll address that a bit later on. Okay, so we have this evaluation problem. Then I talked about, we want to build retrieval models that exploit the characteristics of social data. There's a lot of different types of social data generated by the applications associated with them. I mentioned SMS, microblogs like Twitter, forums, blogs, the hybrid systems like Facebook, hybrid meaning that they have aspects of both microblog and forums, in the sense that you can conduct conversations more easily, things like that. Email is also a social media, the oldest social media, but it's used for conducting conversations, right? Either informal or formal. There are others, of course, that are around, like photo sharing, video sharing, and I'm not going to be talking about those. I'm going to be focused more on the text-based ones. Everything's text-based. I'll take that back. Everything's text-based. I'm going to focus on the ones that have mostly text postings in them. We've also done a lot of work with CQA, which I mentioned up there. That's collaborative question answering, like the Yahoo Answers system, where people answer other people's questions. And clearly that's a great resource for information retrieval. You get huge archives of questions and answers. And so the task then is to take a new question and match it against that archive to find previous answers that match a new question. So it ends up being question matching more than anything else. We've done a lot of work on that. Other people have as well. I'm not going to be covering that today because it's like a whole separate topic. I just wanted you, that is social media though, and that is an interesting part of the research in social media. Okay, if we look at across all of these social applications, some common characteristics of this data is they tend to be short, informal text with rich metadata. There's a lot of metadata associated with a little Twitter post. And some of it's useful and some of it isn't, but there's a lot of it. There's a strong time, typically social media has a very strong time dependency associated with it. And there's also typically a hierarchical conversational structure coming out of most social applications, that you have different conversations going on and that there's dialogue structure within each conversation. Somebody's answering somebody else or somebody further up in the dialogue, etc. So there is a structure there that's important. And of course, there's a social network that some people know each other, some people are experts, some people are not experts, etc. Hierarchical, yes?
I don't know what you mean by metadata in this context.
Well, I'll give you examples later on, okay? Metadata is anything that isn't just the text in the message.
So the fact that it's
Even like the time even, you know, the time that it was issued is metadata, okay? Or even the person who generated the tweet is metadata, okay? Or if it's, if it's email, the person who receives it is metadata as well. So anything that isn't just the actual content, the text content of the message. So these are the sort, you know, I've mentioned this before, and there's a nice unreadable slide for everybody to look at in the first two rows. Just basically saying that in typical forums, you have this hierarchical structure is completely evident, that there are many threads. In this case, it's an Apple discussions forum. There's a support subpart of the forum, and then discussions about using iPad, and under that is the Wi-Fi issues with iPad, and under that is a series of threads just looking at that topic of Wi-Fi with iPad, and then in each thread there's a series of postings, and that series of postings also has structure in the sense that often you see this as a sequential structure, just a list of postings in an individual thread. But of course there's a structure there in that some of these postings are answering the posting right before them, and other postings are answering the top posting, or it could be any posting in between, essentially. The only thing you can't answer is a posting that comes later than you, because that's difficult. But anyway, there is this structure, and this structure is important because even a single post like "I agree" in itself doesn't have much content, but in the context of what you're agreeing with, then that's important. It's another person agreeing with the opinion of the person that you're agreeing with. So these short postings can gather very rich context from this structure, the hierarchy of posts and the conversational structure. And we want to try and exploit that in these models that we develop. The other interesting thing about social text relative to archival text is that they're usually, I mentioned this a couple of times, short, informal, lots of abbreviations, horrendous amount of spelling errors. And the question is, you know, how much does that impact the sorts of techniques that we need to develop? But it's something we need to consider. So, you know, query reformulation techniques are the way we deal with spelling errors and word mismatch in queries in general in search systems. Techniques like query expansion, pseudo-relevance feedback, which is assuming that some of the top-ranked documents are related to the topic and grabbing vocabulary out of those documents. Corpus space stemming, which is basically analyzing word forms that occur in similar pieces of text in order to correct to find other morphological variants of words and when it's appropriate to use them. And log-based spelling correction is, these are all techniques that are in current search engines and have been developed in research. And some of them are applicable to social postings, and some of them are not. So we have some start about how to deal with these things, but we need to understand what will work with this even more informal text with it. It's even worse than the collection of query text that we normally deal with. One problem is that we have generally, the corpuses are smaller. The amount of text that you have is much smaller than you have in a web corpus for most social applications. You also typically have much smaller or even non-existent query logs. Query logs are probably the single most important resource these days that web search effectiveness is based on. And they are still fairly limited in the social media world. A lot of forums don't maintain query logs. They're all scattered between different forums, etc. But there are other resources that we may be able to exploit. And the other problem is that most of our models are probabilistic and need to infer things about vocabulary words and things like that may be related to words that are in posts. And when you have a short amount of text, it's difficult to infer something like a language model, which is a distribution over a probability distribution over the words you may expect to see in that post if the person continued to write, essentially, on that same topic. It's easier to estimate that from a journal paper than it is from a one-line tweet. Okay, so we have problems potentially with estimation, and things like context become much more important, like the dialogue context and conversation context, because they give us other related messages. We get a better idea of what other vocabulary might be used in discussing the topic that tweet's talking about. And it's similar to some problems we've looked at before in information retrieval, like sentence retrieval and answer retrieval, which are both looking at sentence level things and how you retrieve them. Okay, so there's some of the characteristics of this social ephemeral data. And that's what I'm going to give you now are some examples of some search tasks in the social space and how we approach them, so how we exploit some of the characteristics that I just mentioned. And this is still very much, for the field, work under development. We're still understanding social media. We're still understanding search in social media. We're still, and when we get to personal search, we're still understanding what it even means. Because, in fact, there aren't even really many personal search applications even available these days. So most people don't even do it. So this is still very early days. So I'm not presenting this as the final word in any area, just as an example of the types of work that's going on in our area and the sorts of solutions that people are looking at. So under general search, I'm going to look briefly at blog site search, conversation search, and I'm not going to look at some other things that we and others have worked on, like blog opinion search, expert search, which is finding the people who are the most expert in a given topic in a community. As I mentioned, collaborative question answering is another area we've done a lot of work in. I'm not mentioning that. I'll talk about microblog search. And on the personal search side, I'll talk about some work we've done in desktop search, which is a version, even though most people regard desktop search as mundane, generally I feel that's because it works pretty badly right now. And the reason it works pretty badly right now is that people haven't spent much time working on it, and it's difficult to evaluate because of all the issues I just mentioned before. In fact, it's so poor that people like Google even have pulled out of desktop search recently. But it is personal search. That's your personal space. Desktop search is an existing tool for doing personal search. I'll also look at some new work we've done on Twitter and Facebook search and on personal filtering of Twitter feeds. And they're names of students of mine that have been working on these topics. I'll get to answering your question eventually, Jen. When I get to one of those things, I'll show you the actual things that we consider metadata, okay? Okay, blog site search. This is a Trek task, which was defined, I don't know, about 4 years ago? Was it longer ago than that? 4 or 5 years ago?
5 years.
Yeah. So the task is to find blogs to subscribe to for a particular topic. So if you're interested in information retrieval, what blogs should I subscribe to in order to follow, because they have interesting stuff about information retrieval in them. And so that was a need that we decided that was a reasonable search task for the social media of blogs. More recently, this has come back again because it's essentially the same task as finding people to follow in Twitter, right? Because Twitter is a microblog, a Twitter feed, and it's really answering the same. If I'm interested in information retrieval, which people should I follow? So this is so beyond my personal circle of people I'm going to follow. If I'm interested in topics, particular topics, then which feeds should I be following? The ones that we want to subscribe to in this topic-based version of subscription is we're looking for sites or feeds that contain a lot of documents relevant to that topic and that are focused on that topic, because you might be a large blog or feed that contains a few things about information retrieval that are interesting, but they may be 1% of the posts, and I may want to look at the other 99% of the posts, which have got nothing to do with me. I'd rather watch a feed that has lots of stuff about information retrieval in it. So the approach that we did, and other people developed versions of similar sorts of things, was to use a combination of global and local representation to cover these two aspects of having very good relevant posts in it and also having high topic coverage. Global representation is the obvious thing you might try, which is to build a representation based on all the posts from a particular blog. You just look at all the posts in a particular blog or all the posts in a particular Twitter feed, and you build a probabilistic representation, if you're taking this sort of language model approach, of what's the probability of certain types of vocabulary in this Twitter feed or in this blog site. Okay? And that's going to be a representation of the Twitter feed or blog site. And then for a given query, you rank these things by the probability that they can generate the text in the query. Or another way of saying it is that you can construct a language model also of the query generation process and compare those two language models. So that's a very standard approach in information retrieval. So one of these types of models is constructed from all the tweets.
You bumped the cable.
Is it this cable? No. I thought I was in the middle of the. I stood. Maybe it's this one. Anything happening? No.
No. Maybe
Unplug the video, unplug it back in.
yeah, maybe.
Maybe.
It's a hardware problem.
Oh yeah, that's much better. No, all I did was stand on this thing here, which is a PowerPoint.
Yeah, I guess no.
Okay. Is it readable? Barely, yes. Okay. Well, I think I'd rather just push on rather than.
I would just try to get some of it.
So you just put on your rose-colored glasses for it. Okay, so and this other local representation is based on for this topic, what are the best posts for that topic in terms of this probabilistic model? Which posts have the highest probability of being related to the topic, could generate the topic? And then we build a representation based on those. So this one obviously selects feeds that have highly relevant posts in it. This one will select feeds that have lots of relevant posts in it. And then we have a way of mixture model which combines the two. And that works well in the evaluations. This is a typical sort of track evaluation. Here, the two measures we're using are mean average precision, or MAP, which looks at the whole ranking, given a set of relevance judgments for a given query. Well, I'm going to stand in one place here and not move, okay? Because I'm standing on that same iron plate that I was standing on before when it changed. It looks at the whole ranking in terms of how are the relevance documents distributed over the whole ranking. And precision at 10 looks at how many relevant, good posts, good sites or good feeds you got in the top 10, as the name suggests. And so you can see there that this combination of the local and global representation that's actually a significant improvement in this measure for both measures. So that's a good thing. So constructing language models of these feeds for both local and global is an effective way of dealing with this particular task. Okay. See what happens next. Conversation search is another area we've worked in to some extent. We crawled a large part of two forums, the World of Warcraft forum and the Cancun Search forum. The first thing we need to do in those forums is actually discover the thread structure. As I mentioned, I showed you that before. It works again, as long as I stand here.
Oh, good.
Yeah. So this is the structure we want to discover. What are the threads in this conversation? Who responded to whom in that structure? We want to infer that. That is actually not explicit in a lot of forums. It's partially there in some forums. It is there in email. It's clear in email, although sometimes it's recorded incorrectly. But in other forums, it's not even there, and you have to infer it. So first thing we did was build a feature-based model to infer these relationships between postings in a conversation on forums. And that just basically says that the model that we built, which used a bunch of features based on the relationship of a post to where it was to other posts. You've got a high probability of replying to the previous post, and also a high probability of replying to the first post. And there's actually a distribution for given forums of your likelihood of replying to the nth post before you, etc. And the time relationships, if it's 6 months between a posting and another posting, you're less likely to be a reply to them. Authorship, obviously, if you mention a person's name or something, you're more likely to be replying to them. So a bunch of features like that. And it ends up doing a reasonable job, especially in the WoW forum. The Cancun forum missed one important feature in social media applications, which is where you quote a previous posting. That's a very good feature for telling you that you're replying to that posting. You can't even do that in some forums like a Cancun forum, so that feature was missing. It's obviously an important feature for inferring structure. Then given that structure, we extracted different types of dialogue structure. There's the thread itself, there's the individual post, they're the easy ones. Then you've got a pair, which is assuming that you've got a reply of one post to another post. And another structure is a dialogue, which is a whole history of one particular dialogue in this whole conversation. And so we use those different extracted structures as possible, we use them in two different ways, as both retrieval units and also as context to smooth the probabilities we're estimating. So here's a couple of examples. This is thread retrieval, where we were trying to retrieve the rank things on the left-hand side for given a query. But what we're using is we're basically retrieving the best pairs or best dialogues and best posts. It's like the blog post retrieval. We're saying the best thread, there's a global context, which is all the posts in the thread, but there's also, for example, if we rank the dialogues, what are the best dialogues in that thread and how well do they contribute, how well are they related to the topic? So that's more the local context. So once again, it's this combination of local context, global context. We have potentially different local contexts here. This evaluation table down the bottom, which is using yet another measure, which is NDCG at 10, which is ranking how well you did in the top 10 documents, but you get a diminishing return for going further down that ranking, getting a relevant document. Rank 1 is the best you can do. Rank 5, it's still good, but not as good as rank 1. So you get a discount on how the reward you're getting for finding a relevant document. It also allows you to have multiple scale relevance, so you could have a 5-rank relevance if you wanted to. Anyway, so using that measure, the basic message to take away from this experiment is that conversation context improve performance significantly. Just using the posts on their own, looking at the wow column there, posts on their own are a really bad way to retrieve threads. Using the global context is pretty good, it's 0.42, but incorporating the dialogue context into that as the local context in this probability estimation improve the performance significantly. You have to take my word for it that 0.42 to 0.48 is a significant improvement, a noticeable improvement in retrieval quality. And then there's posting search, which is where we're retrieving the second thing from the left. And what we're going to do is use the other things as background context. So language model approaches information retrieval will typically use the whole collection as a context, as a background smoothing context. So that's how we add probability to words that don't occur in the document. We use the background collection, the whole collection. But now we can smooth using these other contexts. The post occurs in the context of a pair, a dialogue, and a thread, and we can use the vocabulary in those contexts to smooth our probability estimates. And that's all that this says here is it ends up being a mixture model of these multiple contexts. The interesting thing about this is that a given post can occur in multiple contexts of a given type, so you have to average the multiple dialogue contests that a post can occur in, for example. And we use geometric averaging for that because it works better and there's a good justification for it. Anyway, once again, the bottom line is that in this posting retrieval, the best results obtained were by smoothing the post with the context of the conversation, the pair conversation. The dialogue conversation helped significantly this was done with the Trek email collection. So it's email now where we're absolutely certain about the structure, basically. So especially in once again, the dialogue context led to a significant performance improvement.
A quick question?
Yeah.
How the smoothing parameters are specified here? Could you please elaborate a bit?
Well, we do cross-validation, okay? Or for some of so for the forum collections, we built them ourselves. So we don't have huge numbers of queries. We're using queries based on thread topics, and we ask people to generate queries related to thread topics. So we have about 60. So we decided to do cross-validation in that case. Okay? This is the Trek microblog search, which is a new track this year. This track attracted the most participants of any Trek track in its first year. Something like 212 participants doing this one task. And they only just defined the task right before the track. There's a lot of discussion of what does search look like in Twitter. This is global search again. So the task is to find the most relevant and recent tweets on a topic, database of 1.6 million tweets sampled during a 2-week period, 50 queries with a timestamp. The evaluation measure they used was precision at rank 30, how many relevant ones you found. They also didn't discount for novelty, so if you could find the same thing said over and over again in different tweets, each one was counted as relevant. So this is obviously first year, needs refining. We used 2 different approaches which refined the ranking function using a quality model and also a time-based model. I can say a little bit about that. We trained the quality model based on retweet data. You all know about retweets in Twitter, I assume. Obviously, you can get a lot of retweet data, and what we assumed was if we trained a model predicting retweeting, that would have something to do with quality, that quality tweets are more likely to be retweeted. And so we trained this model using retweeting data and then used it as a quality model to affect the ranking. The time-based relevance model is a technique for looking at, in the top-ranked documents, to look at documents that occurred close to each other in time and to build models of the vocabulary uses in these different time periods. And for blog site search, that had a big impact on the effectiveness of the search because the discussion changed over time and modeling what was happening over time was significant. And then we used a bunch of baseline approaches here. Query likelihood is the language model approach I mentioned, where you predict the probability of generating a query from the model that represents the document. sequential dependence and the relevant is sequential dependence is a proximity version of that. You can think of it as using n-grams instead of unigrams if you like, although it's more complicated than that. And relevance model expansion is assuming that some of the top ranked documents are relevant. You expand the initial query using words from those top ranked documents. These are the example queries in the Trek Microblogging track. Nothing particularly exciting there. They have the time associated with them. These are the types of features in our quality model. So there's features dealing with how interesting the words are at the top. Then there's features about how long the tweets are and how much they're made up of characters and versus other types of letters rather than other types of characters. Features associated with whether there are links present, hashtags present, named entities, certain types of dates, exclamation marks, question marks. So all things that we can derive from the content of the tweet. Okay, so how good did this do? So this is our own data before we got the Trek data, and it basically says that the relevance RM is relevance model. Baseline, the Dirichlet one is the simplest version that you could do, just this simple query likelihood with Dirichlet smoothing. It says that relevance model, which is a form of query expansion, is really important to get good retrieval. Because tweets are short, you need to expand the query, essentially, to have a higher chance of hitting the interesting stuff. So matching exact words, which is none of these models, is worse than any of those. So it's not the right way to go for tweet search. SDM RM is using a proximity restriction between the words that turns out not to matter that much. You might expect that because tweets are short. So adding additional proximity constraints doesn't buy you that much, as opposed to when you're searching journal articles, saying that words should occur near each other is obviously much more significant. And temper is the time model, which actually improved things a bit in this database. Quality didn't have much impact. That's the blue bar, and basically the way we were using it didn't improve much at all. Okay, this is the Trek data with the results that just came out last week. And we see similar sorts of results in that the relevance model, the query expansion, is much better than the baselines. That proximity doesn't help you much at all. Mustafa is actually he's the author of the time-based model. So in this case, the time-based model, and this task, remember, was finding recent tweets. So finding tweets from other time periods actually doesn't help, as you might guess from the task. So that didn't help that much. And the best one was the relevance model, or the sequential dependence proximity one combined with the relevance model. But the big thing here is that the quality model, the purple one, made a significant difference in every case. So we're predicting quality based on retweeting and then incorporating that in the ranking, and that significantly improves things. Okay, right, I've got a few more things I want to cover yet. I actually think in some ways this is more interesting because it's more challenging. Personal search. So desktop search is the obvious example of personal search. This is actually a whole field called PIM by some people, Personal Information Management. And you've seen examples of this. There's all this work on life logs. It actually got banned in the United States when we started doing it because of a DARPA thing. Anybody remember that? The head of DARPA research at that time was, what's his name? Tannenbaum? No. Anyway, he was a guy who was associated with the CIA beforehand, and therefore a lot of people came out and said, what is this LifeLog program where you're recording everything that people are doing? And the CIA are involved with it. Clearly everybody's trying to get into our privacy. Congress banned us from working in that area. We're funded by DARPA, whereas Europe just went ahead and did it. But anyway, it's a popular thing to talk about in research. How do you have a personal memory over many years of things that you've done and experienced? And that's a similar type of thing. So now we've actually got that in default. That's what social applications it's gathering a lot of your personal experience. To think of what you put on Facebook or in Twitter, you're recording a lot of your interesting life history in these social applications. So it's another way to look at this idea of personal memory. It's an expansion of what you've done in email. And so a continually expanding range of stuff being captured, geolocation, everything about you being captured. And so because of that, the types of search, from a search perspective, the types of searches are going to change. We now know what is a search on personal memory. It isn't like a typical web search where I want to find information about this topic or I want to buy a book. Now we're talking about your own personal memory, stuff you've done in the past. What does the search look like? Known item seems reasonable. I said something to somebody a while ago, or I remember seeing something there, so I need to find that interaction again. And so it's known item search. That's pretty well known in the database and information retrieval literature as a type of search. I think it's very important for this type of application. But there could be many other types of searches, like simply what I call browsing down memory lane. I just want to look down, just try and have fun scanning what I've done in the past, get reminded of interesting things I've done, places I've been, there's photos you see, etc., and other things. Filtering obviously becomes more important because there's so much garbage in things like Twitter and those types of streams that any type of filtering would seem to be a good thing to be working on. Okay, we've done a lot of work on desktop search recently, and it does have a lot of similarities to social search because there's multiple data types, there's rich metadata. That phrase again, it includes email, desktop search, and it's personal data, and everybody has privacy concerns about it. So it's just like social data in that sense. So what we wanted to do was to study. Nobody had really done a study of how retrieval models compare on desktop data. There aren't papers about that because there aren't desktop data collections that you can work on. And so what we've been doing the last few years is to both develop new models which try and infer which field that you're talking about in a query. It tends to make some difference. But also a model for evaluation where we've developed pseudo collections, which is artificial collections resembling desktops in various ways, containing the same types of data, personal, associated with a particular person, but generated artificially. And also generating queries, which are for known item search associated with that collection. And we continue to work on making these things more real using various measures, both statistical measures, comparison to actual queries, and getting people to look at them and say whether they look reasonable, etc. We've also been using memory games a fair bit where we show people documents from their personal collection and ask them to generate queries to find those things again. So there's been a thread in the evaluation research community is developing games to get lots of queries in a short time from a number of subjects. And we've been looking at all those things. So in the Facebook and Twitter area, we tried doing the same thing. We collected personal archives of Facebook and Twitter for a bunch of people, willing people. So stuff that they'd seen over the last 6 months. So we're not interested in the stuff you generated as so much as things that have been sent to you, or things that you're following, what your friends are doing, what you're following on Twitter, because that's the stuff you're more likely to query. You also incorporate your own things. These are some fields, Jen, for these things, for Facebook and Twitter. A lot of these are metadata. Usernames of posters or receivers. There's the main text, which we don't consider metadata. Creation time, update time, usernames in comments. That's not metadata. Comment text, comment creation times, people who like things, they've clicked it as like. That's not in the content, so it's metadata as far as we're concerned. Okay. Links, that's part of the content. Descriptions of link content, usernames and photos, and then Twitter, some other fields as well. So a bunch of stuff. We collected queries from a couple of different versions of games. So we got the people whose data it was to generate queries to search their own data using these games. One thing, that top table shows you for our these users that we had, how many Facebook posts and Twitter posts were in these collections, which are based on the last, I think, 6 months. You get big numbers. These are not little search systems in the sense we're talking about tens of thousands and so over 100,000 is not unusual, postings in Facebook or Twitter that you're searching. So it's a significant search problem. And if you go back any further than that, obviously the numbers get bigger. And these were selected, these were not people who are heavy users either. Then there's these things here are just showing the characteristics of the queries you get from different types of games. And so that's game 1, game 2, game 1, game 2 from Facebook and Twitter. You can see that the queries from game 1 tend to be shorter. That's a length distribution on the middle graphs. And this shows the overlap with the content of the documents, which basically this graph says that the first game got people to submit queries which were always exactly contained in the documents, whereas the second game got people forgot what was in the original documents. So they were generating queries which had only some of the words were actually in the documents, which is probably more realistic for this type of memory query. Results, just summarizing at very high level, the simplest model works pretty well for this Facebook and Twitter retrieval. The model that worked better was to infer the parts of the queries or queries that deal with people. And that's the most important field. This is just a bar chart here showing what fields are associated with the different words in these queries. The main text is one of the popular ones, but the username is also one of the most important fields. It's not surprising. People tend to generate queries about people. And if you infer that certain words are about people, it improves the results. So a simple result, but it makes a big difference in the effectiveness of ranking. Alternatives, you could do online testing, you could build a system, because nobody really does this right now, so we don't really know what these queries look like in an actual system. So one of the things we've done is to build an Android app with a team of undergraduates using one of our Lima search engines, which runs on Android and is available. So we're going to start distributing that like next week, and it's got a facility for gathering the data on queries. So we'll be distributing it to people who agree to do this stuff with us. And finally, building topic-based archives. I don't have time to talk about that. There's some examples from this. I just got them last night, so apologies for the garbage on the bottom, because I was too cheap to get the professional version. But this is so it shows you a mix of the Facebook, Twitter postings that are sent to you, so you can scan them all. And this just shows that you post, when you choose to, you post the tracker base, which posts the query log to our researchers. And this is showing just a search on the search queries, social search, and a bunch of Facebook and Twitter postings. The ranking algorithm uses a combination of field-based importance and things like that to come up with this ranking. So once we have more data, we can do more comparison of how well these different algorithms work. Final thing I want to talk about is personal filtering. And I won't have time to say much about that, but basically the idea here is to predict the interest level in a tweet for an individual user. So there's two main tasks we're looking at there: predict if the post will be retweeted by a specific user, and predicting which users will retweet a post. So what we want to do eventually then is be able to show tweets to individuals in ranked order. Okay, and hopefully in ranked order that's related to interestingness, so that a lot of the less interesting stuff is lower down the ranking, to make it easier for people to scan when they get hundreds and hundreds of these things. And predicting which users to retweet a post, we're seeing how well we can rank users for each tweet as to which people are more likely to be interested in a given tweet. And we, once again, have a whole bunch of features. The interesting stuff about this work is we use a lot of the social network features, who follows who, etc. And that turns out to be a very important set of features in this task of predicting who's going to tweet and which things are most likely to get tweeted. And I'm going to skip all that just to say that we can actually do a pretty good job on these two tasks: ranking tweets for individuals and ranking individuals for a given tweet. So there's a lot of potential promise for these things. And as I say, the best features tend to be these social network features about who follows who. But there's other stuff, just like people who post a lot tend to be good retweeters. Yeah, I'm skipping all that. We did one study at the end to say, well, our assumption was that retweeting behavior is relating to the interestingness of the tweet. We did a very small initial study to measure how true that is, and we're able to show that based on interestingness, not on likelihood to retweet, that our model, which incorporated the retweet model, was actually no better than the default Twitter model, which is just straight time-based presentation. But as soon as you get to rank 5 or rank 10, it improves significantly relative to producing, to sending things in temporal order to people. So, future directions. One slide here. This ephemeral data, there's multiple layers of ephemeral data coming from different types of applications. Forum data, blog data, microblog data, they each have their own characteristics. They're each interesting. They've each got their own set of connections and interconnections, and they've each got social networks going on. These are the different types of nodes there. Links between postings, links between people and postings, links between people. So there's a very complicated social web over in this ephemeral world. Then there's the web we're more used to dealing with, and the archival information, where we know that links between web pages are very important in terms of producing effective rankings. Things like anchor text are really important features. And so there's a whole wave of research waiting out there to saying, how do we incorporate all these structures into useful models for retrieval? Both retrieval of social data coming from that side, we can enhance social data retrieval using links with archival data. That's sort of obvious in a way. If you link to a web page, and that web page obviously could tell you a lot about what's being talked about. But that's a very simple version of it, and we have potential for a lot more interesting network-based models. And also improving the web search itself, in that the social side gives us, as I've said a number of times, a lot of data about the opinions related to the archival data, but also in enhancing what's said in the archival data. Often very interesting information is revealed in the social commentary related to archival data. The black nodes there indicate topic linkage. So there's explicit links and also implicit links. And so there's a lot of scope for developing new models with this view of what's going on. Other areas that we plan to work on and push are conversation search, I think is a really interesting one. Every social media, including Twitter and others, have forms of conversations. The idea of retrieving conversations instead of individual postings, I think, is a really key idea for social media. That's really a lot of what people are interested in is a conversation. Aggregated social search is how you combine different types of social media into an integrated ranking, same way we do aggregated search on the archival side right now, like a typical web search where you get a map result, and then some web pages, and then a page from some other type of vertical. Same problem on our side. Cross-lingual retrieval, this something we looked at in the 90s, but social data is incredibly cross-lingual. You know, look at Twitter, there's just amazing amount of cross-lingual stuff. Everybody's talking about the same topics in a whole slew of languages. There's an incredible field of data there to be mined for learning about cross-language use. And as I said, I think browsing and searching personal archives is really an important problem, which we don't really know much about. Managing diffuse identities is still a diffuse idea, but it's basically the idea that you have lots of identities. You have an identity in this forum, a separate identity in another forum. Every